Hello, now we'll consider another problem on the cable. A cable of uniform section is used to span a distance of 40 meter as shown in figure. The cable is subjected to a UDL of 10 kN per meter. The left support is below the right support by 2 meter. Lowest point on the cable C is located below left support by 1 meter. Evaluate the reactions and the maximum and minimum values of tension in the cable. Okay. If you look at this left support is below the right support by 2 meter. Means the difference in level between the supports is 2 meter, that is 2 meter. Lowest point of the cable is below the left support by 1 meter. This is, we can say it as YC now. So usually this is carrying UDL of 10 kN per meter. UDL can also be shown like this. So you know that horizontal distance between A and C is L1 and C and B is L2, but here L1 is not equals to L2, but L1 plus L2 equals to 40. Okay. So now first we need to calculate the value of this, what we can say, L1 and L2. So we know that relation L1 by L2 is equals to, here earlier I have written YC plus D divided by YC. Now here it is YC divided by YC plus D. See, always you have to write like this. L1, this is dip of the cable with respect to A, and this is the dip of the cable with respect to B. Here dip of the cable with respect to A is 1 meter. Dip of the cable with respect to B is, this is D plus YC. So if you simplify this, that is what is the L1 here, this YC here, this is 1 meter, YC plus D is 3 meter. So therefore if you calculate here L1, you will get the answer as 0.577 L2. But what do you know, another, see, one you get to L1 in terms of L2. So we know that, but L is equals to what here? L1 plus L2. So L1 plus L2, this L is 40. L1 is, let us write 0.577 L2. This is plus L2. So if you simplify this L2, so you are going to get the answer as 25.36 meter. Okay. Therefore L1 equals to 0.577 L2. So you will get the answer as 14.64 meter. Okay. So once if you get the value of this L1 and L2, now what is Lx? You have to calculate the reactions. So how do you calculate reaction? First let me calculate H, because this is also carrying what you can say a uniformly distributed load. So for a cable having uniform distributed load, you know that the formula is WL square by 8YC. But here it is the cable which are supports are at different level. So here W is W, that is intensity. But here L1, for if you want to calculate this as HA, with respect to A as origin, L will be now 2L1. So it will become 2L1 square divided by 8. YC is dip of the cable with respect to A. That is here YC itself. Now if you simplify this, W is given 10 kN per meter. 2L1, that is 2 into 14.64 square divided by 8 into YC is 1 meter. So if you simplify this, you will get here 1071.65 kilonewton. Okay. So first you have to get L1 and L2. Once if you get the values of L1 and L2, you need to calculate HA and HB. HA for a horizontal, for a cable carrying purely vertical load, the horizontal reaction at both support will be same. So this is also nothing but HB, or you can say H, because sigma fx equals 0. So minus HA plus HB equals to 0, hence HA equals to HB, that you will get. So once if you get this HA and HB, now we will calculate the reactions, another reactions we can say these VA and VB. So VA and VB we can calculate by writing sigma MB equals to 0. Okay. So if you take this moment, algebraic sum of moments of all the forces about B, first VA, what is that? It is causes clockwise VA into 40, because you are taking the moment about B. Then this UDL, as usual, it is minus 10 into 40 into 40 by 2. Okay, this is clockwise, this is anti-clockwise. Now h, what will cause here? H will cause, because you have to turn this h towards the upper support now. This way it will be, again it is clockwise, so it will be plus h into, what is the distance between this support and this support? That is 2. H into 2 will be equals to 0. See here, very important is, support if you, this h is, this right support is higher, this h is outward, so it will cause clockwise. Suppose if this right support is lower than the left support, you know that this way you have to turn this towards lower support now. This will cause anti-clockwise. Here this will cause clockwise, whereas if this support is lower, this will cause anti-clockwise. Whereas here this VA is causing clockwise, UDL causing anti-clockwise. But H, it depends upon whether support is lower than that or upper than that. If it is upper, so you have to turn towards up, that is clockwise. If it is lower, right support is lower, you have to turn towards lower, this will be anti-clockwise. So okay, now if you substitute the value of H, which you have got already, what is that H we have got now? That is 1071.65. So you will get the value of VA, which you will get it as 146.42 kilonewton. Okay, then writing by sigma Fy equals 0, you can get the value of VB. That is VA plus VB is equals to or minus equals to 0. If you transfer minus, it will be right side plus 10 into 40. So therefore VB is equals to, this is 400 minus VA, that is 146.42, will give you 253.58 kilonewton. So once if you get the VA and VB, what he has asked here, evaluate the reactions. Okay, H is over, VA is over, VB is over. Maximum and minimum value of the tension. See, I said that maximum tension will be at the support at A or B. If he asked calculate the tensions at A and B, you calculate both. That is here, you know that TA, that is tension at the support A, is VA square plus HA square. Of course, HA is equals to H. And if you want to calculate the support tension at support B, it will be TB. This is equals to VB square plus HB square. Right? Here HA and HB is same. Only VA and VB are different. So when automatically little consideration, if you think, or what you will say, if VA is greater than VB, TA will become maximum. If VB is greater than VA, TB will be maximum. So in our case, VB is greater than VA. Therefore, maximum tension will be at support B, that is nothing but TB. So this is nothing but VB square plus HB square. Right? So if you substitute the values of VB equals to 253.58 and H as 171.65 and simplify this, so you are going to get here 1101.4 kilonewton. Okay, this is the maximum tension. Suppose if he asks calculate tensions at A and B, you have to calculate both TA as well as TB, but he has asked to calculate maximum tension, so it will be here. This is TB will be the maximum, and hence you are going to calculate. Now what is the minimum tension? See, minimum tension means if you calculate here anywhere, suppose if you take this as the lowest point, right? So here VA, this is H, and here if you draw the curve or a slope line, it will become horizontal. So if this is theta, say if this is T and if this is H and this is say VA something, so always know that if you write sigma fx equals 0, what you will get here? T cos theta will be equals to H. Right? So means T will be minimum. T will be minimum. Okay. Minimum when theta is minimum. Okay, what is the minimum theta value? That is 0. That is when theta is equals to 0, so automatically t will become minimum. Hence, therefore, so cos 0 means 1, so it will be t into 1, that is 1, and is equals to h. So when theta is minimum, this will be, so automatically this t minimum, this t will become automatically now in this case. So here what I said, t cos theta is h, so t will be minimum when theta is minimum, that is theta is minimum is 0, maximum is 90. So when theta is 0, automatically t will become minimum. So t cos theta, cos 0 means it is 1, so it will be t into 1 is equals to h. So in that case automatically t will be minimum and this will be equals to h, and therefore t minimum is h, already you have calculated, that is 1071.65 kilonewton. T maximum is either VA plus HA square root of that, or TB VB square plus HB square. If VA is greater than VB, TA will be maximum. If VB is greater than VA, TB will be maximum. But minimum tension is always the H, that is T minimum will be always the horizontal component of that support. So T minimum is equals to H, that is 1071.65 kilonewton. Whether supports are at same level or different level, always T minimum is equals to the value of horizontal thrust itself, that is whatever the horizontal thrust for that problem we will get, that will become the minimum tension in the cable.